Hi, in this video, I will share the IGNU MCA Data Communication and Computer Networks January 2024 session solved assignments. What is packet switching? What is circuit switching? Compare them. What is circuit switching? Circuit switching is a communication method where a dedicated communication path, or circuit, is established between two devices before data transmission begins. The circuit remains dedicated to the communication for the duration of the session, and no other devices can use it while the session is in progress. Circuit switching is commonly used in voice communication and some types of data communication. An analog telephone network is a well-known example of circuit switching. Bandwidth is fixed in this type of switching. Advantages of circuit switching. Guaranteed bandwidth. Circuit switching provides a dedicated path for communication, ensuring that bandwidth is guaranteed for the duration of the call. Low latency. Circuit switching provides low latency because the path is predetermined, and there is no need to establish a connection for each packet. Predictable performance. Circuit switching provides predictable performance because the bandwidth is reserved, and there is no competition for resources. Suitable for real-time communication. Circuit switching is suitable for real-time communication, such as voice and video, because it provides low latency and predictable performance. Disadvantages of circuit switching. Inefficient use of bandwidth. Circuit switching is inefficient because the bandwidth is reserved for the entire duration of the call, even when no data is being transmitted. Limited scalability. Circuit switching is limited in its scalability because the number of circuits that can be established is finite, which can limit the number of simultaneous calls that can be made. High cost. Circuit switching is expensive because it requires dedicated resources, such as hardware and bandwidth, for the duration of the call. What is packet switching? Packet switching is a communication method where data is divided into smaller units called packets and transmitted over the network. Each packet contains the source and destination addresses, as well as other information needed for routing. The packets may take different paths to reach their destination, and they may be transmitted out of order or delayed due to network congestion. Advantages of packet switching. Efficient use of bandwidth. Packet switching is efficient because bandwidth is shared among multiple users, and resources are allocated only when data needs to be transmitted. Flexible. Packet switching is flexible and can handle a wide range of data rates and packet sizes. Scalable. Packet switching is highly scalable and can handle large amounts of traffic on a network. Lower cost. Packet switching is less expensive than circuit switching because resources are shared among multiple users. Disadvantages of packet switching. Higher latency. Packet switching has higher latency than circuit switching because packets must be routed through multiple nodes, which can cause delay. Limited QoS. Packet switching provides limited QoS guarantees, meaning that different types of traffic may be treated equally. Packet loss. Packet switching can result in packet loss due to congestion on the network or errors in transmission. Unsuitable for real-time communication. Packet switching is not suitable for real-time communication, such as voice and video, because of the potential for latency and packet loss. Similarities. Both methods involve the transmission of data over a network. Both methods use a physical layer of the OSI model for transmission of data. Both methods can be used to transmit voice, video, and data. Both methods can be used in the same network infrastructure. Both methods can be used for both wired and wireless networks. Difference between circuit switching and packet switching. Basic operation. Circuit switching. In circuit switching, a dedicated communication path is established between the sender and the receiver for the entire duration of the communication session. This path remains reserved exclusively for that communication until the session ends. Packet switching. Packet switching breaks data into smaller units, called packets. These packets are individually routed from the source to the destination based on network conditions. Different packets of the same communication can take different paths and may arrive out of order, requiring reassembly at the receiving end. Resource utilization. Circuit switching. In circuit switching, resources, bandwidth, links, etc., are allocated for the entire duration of the communication, even if data transmission is not continuous. This can lead to inefficient resource usage, especially if the communication channel is idle for long periods. Packet switching. Packet switching allows for more efficient use of resources since bandwidth is shared among multiple communication sessions. Resources are allocated on demand, so idle resources can be utilized by other communications. Connection establishment. Circuit switching. Establishing a connection in circuit switching involves a series of steps, including circuit reservation and path establishment before data transfer can begin. This process can be time-consuming. Packet switching. In packet switching, no dedicated path needs to be established before data transmission. Packets are simply routed based on the destination address, making the setup process faster and more dynamic. Delay. Circuit switching. Once the circuit is established, data transmission typically incurs minimal delay since the path is dedicated. Packet switching. Packet switching introduces variable delays, as packets may take different routes and encounter varying congestion levels within the network. This can lead to packet reordering and additional processing overhead. Robustness. Circuit switching. Circuit switching is less resilient to network failures or congestion since a single dedicated path is used for communication. If the path is disrupted, communication is interrupted. Packet switching. Packet switching networks can reroute packets dynamically in case of failures or congestion, making them more robust and adaptable to changing network conditions. Examples. Circuit switching. Traditional telephone networks, PSTN, utilize circuit switching. Packet switching. The Internet is based on packet switching, where data is broken into packets and routed through various nodes to reach its destination. In summary, circuit switching provides dedicated resources but can be less efficient and flexible compared to packet switching, which dynamically allocates resources and is more adaptable to changing network conditions. Thank you.